Okay, yeah, let's get started. Good morning. It is an honor to be standing here today and to be introducing a scientist whose work has not only shaped the field that I personally work in, but also our astronomy department in Santa Cruz. Sandra Faber got her BA in physics at Swarthmore College, followed that up with a PhD from Harvard, and in 1972, I think, yes, 1972. And right after that, right after that, she moved here to join the Lick Observatory as the first woman on staff. So yeah, for nearly half a decade, her career and the rise of the UC astronomy department have been deeply entangled. Her graduate student and her discovered the Faber-Jackson relation, the first scaling relation for galaxies that allowed us to really measure the deep cosmos. And she co-authored two works that were extremely influential on dark matter that led to the scientific community understanding it and understanding how it impacts structure formation and, well, to dark matter being the accepted part of the standard model today. So she literally changed the way we understand the universe. She did not just make scientific discoveries, she also helped build the tools to build them. She was instrumental in designing the Keck telescopes on Hawaii and was one of the key scientists who found a flaw in the Hubble Space Telescope after launch, turning a potential disaster into one of science's greatest successes. Her awards are too many to mention, but just a few. She's gotten a Presidential Medal of Science, is a member of the National Academy of Sciences, has gotten the Gruber Prize in Cosmology, and a gold medal from the Royal Astronomical Society. In recent years, she's gained a unique and urgent perspective on our home planet through this astronomical gift of cosmic time that we have, the knowledge that our planet could be stable for another billion years and host life. So this imbues us with a profound custodial responsibility for Earth that Sandra calls a jewel of the universe, which I think is a very nice phrasing. So she helped us understand our place in our universe and is now helping us understand our responsibility within it. Please join me in giving a very, very warm welcome to Dr. Sandra Faber.
Thanks so much, Sven. Pleasure to be here. I decided I wouldn't really speak about my science today because I think I might be more useful and more interesting to you if I get you to think about your future. So as Sven implied, as a cosmologist, I'm lucky to have the responsibility to think about large spans of time. And I think I come to those questions, as all astronomers do, with the ability to envision that the future is going to be different. Once the universe was 10 to the 27 degrees Kelvin hot and rather smooth, and now it's 3 degrees Kelvin cold and full of lumps that we call galaxies. So astronomers understand innately that the past is not necessarily like the future. And I want you guys to think that way today about your own futures. So I'm looking for feedback. I've never given a talk like this before. After the talk, maybe over lunch, you'll tell me whether these remarks were helpful to you or not, and how they could be made even more helpful. All right, well, with that as an introduction, here's my talk. You will make history. This is a unique moment in the history of human beings. And I used to think that I was sort of living through the Acme. No, but you guys are the ones who are going to live through crucial changes that we've never seen before. In addition, of course, on this slide is a picture of Saturn from a unique perspective. I did have to weave in some astronomy. And so at the very end of my talk, I'm going to come back to this picture. And by then, I hope you'll see how it's actually relevant to how you should think about your future. Okay. Well, you guys are postdocs. Do is inspire you to be powerful and have impact. So what better way to start my talk than with the story of, thank you, Sven, the Hubble Space Telescope and two postdocs who were products of UC Santa Cruz, who came forward and actually saved the Hubble telescope. You probably don't know this story, but I'm not exaggerating, they really did. All right, so here is Hubble 6 months before launch at Lockheed over there in Sunnyvale. And here's the launch 6 months later, April 1990. Great anticipation. Hard to overestimate how the country was looking forward to these fabulous images. And that's what they looked like. This was so-called spherical aberration disaster. This is what a star looked like. There was a small point in the middle, a bright point here, but a cloud of out of focus photons that completely destroyed the scientific utility of these pictures. This is what we thought we were going to get, and that's what we actually did get. No exaggeration to say it was an absolute disaster. All right, so here's our first hero, John Holtzman. He was my grad student, and as a grad student, he developed tools to analyze the Hubble point spread function. And he was going to use those tools then to actually do science. The same tools, though, he was beautifully positioned to use those tools to analyze the bad optical performance. So together, he and I coaxed the project to take a series of images through focus. There are 6 images here. We moved the secondary mirror of the telescope and we moved the focal plane through the various stages. These are what were observed, and those up there are what John managed to calculate using his tool, which he had learned how to use during his thesis years. There had been 2 months of dithering with the project. Experts, PhDs in optics, were struggling to analyze these images. They didn't look at them this way. I can't go into details. We were simpler. We looked at the whole image. It all became clear. I remember so vividly the day John stood up. He had never spoken in this forum before. He stood up. He presented these pictures to project management, and you could hear a pin drop. Because what had been a mystery for 6 weeks about why the telescope wasn't performing, there was no argument anymore. And it was a disaster. That was the other point that was so evident. Now, John was a very capable person, still is. He's a professor in New Mexico now. And he went on to co-lead the team that built a new camera that was later installed. That took 3 years. 3 years later, he was honored with the role of standing up in front of the American Astronomical Society in Philadelphia and presenting the before and after pictures and the plan, what they had been doing, the fix. And he received a standing ovation when this pair of pictures was presented. All right, so that's John Holtzman. The second is Todd Lauer. Todd was my student earlier on. And this is a picture of the two of us testing the wide field camera at JPL, vacuum tests. Now, in his thesis, Todd developed other tools. He developed an image analysis tool, very flexible, which he could write simple commands that would manipulate images and do calculations. When Todd learned of spherical aberration, overnight, he wrote a program with 6 lines in it in his code environment, which could deconvolve images. That is to say, with knowledge of that horrible point spread function, his program could sort of figure out if the image was bright enough he could stuff the photons back into the right places and recreate an image that almost duplicated the precision and resolution of the original. So the day after, 2 days after John Holtzman stood up and convinced the whole project that it was spherical aberration and how bad it was, NASA, to its credit, gave a press conference. And the only bright spot in that press conference was Todd Lauer, who made a simulated image of Saturn, actually, and showed how the spherical aberration could be undone with deconvolution. Why was that important? Because everybody knew that fixing the telescope was going to take a while. It took 3 years. And in the meantime, what was the public going to think about Hubble? Hubble trouble, Hubble sees double. I mean, there were so many cartoons. It was really the worst moment, worst embarrassment for NASA. It was this deconvolution approach that managed to get some science out of the telescope and give the public hope, a glimpse of what actually could be accomplished if they had the patience to sit through and wait for the fix. So together, these two guys, I think, were responsible for saving the telescope. As you know, Hubble went on to do many, many wonderful things, including looking back in time and figuring out how galaxies evolve in the universe. But to summarize here, these stories show how youth can speak truth to power, provided they have the facts and the courage. And those two circumstances were really borne out here. And I'd like to give you inspiration, your generation's voice, with fresh views and fresh values. Fresh values, very important. We'll come to that. I believe your moment is coming. Now, let me say a few words briefly about myself. As I say, I've been studying how galaxies evolve. Galaxies are needed to make planets. And so I think of this as one chapter in our human roots. But late in life, my father's words began to ring in my ears. It was always, I heard this 3 times a day at least, Sandra, make yourself useful. And so I began to wonder, how useful is this knowledge that astronomers have been accumulating? And I began to think about this, ultimately convinced myself that it's extremely useful, and I hope to do the same with you today. So I call it Cosmic Knowledge and the Future of the Human Race. Now, one aspect that we all care about is what astronomy can tell us about whether Earth is common or not. So, are Earths common? Well, one view is yes. You probably all heard of the Drake equation. Frank Drake was a dean of natural sciences here at one time at UCSC. So don't worry about the details here. What we're trying to calculate is the number of intelligent civilizations in the galaxy. And we start with the number of stars and we do some multiplication, sorry. The key point is that there are 6 terms in the original Drake equation. By the way, Frank Drake was the first person we know of who really sat down and tried to think, are there intelligent beings out there and can we communicate with them? Okay, but here's another point of view, recently espoused by 2 other people. I call it the rare Earth equation, and they have a different take on things. For example, their view is that having a very large and massive moon is very important for life as we know it on Earth. Now, the real difference between this equation and the previous one, that one had 6 terms, this one has 10. Now, if every one of these terms has a 10% probability of coming true, which I think is even optimistic, you can see that if we start adding terms, we begin to get very, very small numbers of Earths in the galaxy. So now here is Sandy's list of terms. There are 17 of them. I'm not going to go into details on this, slide, this one, this pair actually is the subject of a recent paper by collaboration between Earth planetary scientists here, Francis Nemo and Joel Premack in the physics department. Suffice it to say, 17 terms. If each one of those has a probability of 0.1, and there are that many stars in the galaxy, then the probability of finding Earth in our galaxy is like 1 in a million. You'd have to look at 1 million galaxies to find a planet that looks like ours. This is my view. We hear all the time that there are planets around all these stars. Yes, they are there, but I don't think we would want to visit them. And that's what we really care about. I really think Earth is a jewel, and it should be the first galactic national planetary park. Okay, now this makes you think. I think this is, I'm sort of now bringing these facts down to how they might influence our thinking about where we go from here as an intelligent species. So what are some lessons from cosmology? All right, so lesson 1, this is my view. Very important to say that it's my view. We got here according to the laws of physics. We are subject to those laws, and we have to live within them. In other words, there were no miracles in our past, at least after the Big Bang. The Big Bang might have been a miracle, but after that, there were no more, and there will be none in the future. I think if you are a religious person and you think that God is looking after us and created us, you might not agree with this. So I put it forward as my view, and we can have a discussion about whether you would agree or not. Okay, lesson 2, we're learning that Earth can provide a livable home for a long time, 100 million years. That is a long time compared to how long we've been in existence. We have been given a gift of cosmic time. Will we use it well, or will we squander it? And that's the moral dilemma I want to present you with today. I think that question is front and center before us, and I submit that we're really the first generation of human beings to realize and face this challenge. We're the first generation to know enough about our cosmic past to see how we got here, and at the same time to understand our cosmic situation. This is a wonderful solar system. Very stable, not likely that we're going to be ejected into interstellar space by the perturbations of Jupiter or something like that. No, we're very, very lucky, and we have a possible future. What are we going to do with it? That's the question I want you to think about. Okay. So taking a somewhat longer view of planning than people normally do, especially in presidential campaigns, there are 3 things I think we should be thinking about as a society, but we are not. Let me begin with this number. What do you think this number is? Nobody knows. Okay. Obviously, why would you? Okay. Well, this number raised to the power of 1 million happens to be a factor of 2. Why am I talking about it? Because this is the amount of annual growth that we are permitted in the economy if over 1 million years, and I just sort of picked 1 million years as an example of a long time, okay? If we're going to not exceed or increase our economic and footprint on the environment by more than a factor of 2. Small number. In contrast, what is this number? This is capitalism's target, 3% growth compounded over 1 million years. So why are we talking about this? It's obvious, isn't it, that we're in an unusual and temporary period here of economic growth. And I worry that the system that we've set up really depends on this growth in order to be healthy. So here's one view of capitalism. capitalism by its nature entails a constant process of motion, growth, and progress. That's one view. Here, and I've searched for a quote, and I cannot find this. I would like to find an economist who said the following, that interest and dividends are Ponzi schemes that are both premised on having future growth. Capitalism does not bestow growth, no. As an option, no, it needs it. It feeds on it, and in so doing, it's devouring the planet. You don't find mainstream economists writing this way, especially in the Wall Street Journal. It is not fashionable to think that way because the powers that be would find this a threatening thought. But it's true. Economic growth is tied to physical growth and physical resources in real terms. Here's the copper production for the last 110 years, growing at an annual rate of 3.3%. And as a byproduct, of course, there's more waste and pollution. This is plastics production and plastic waste generation for the past 65 years, also growing exponentially. So just for the fun of it, I made one of these word clouds for capitalism. Pretty cool. Economic, trade, market, investment, savings, et cetera, et cetera. Here, in very small print, is the word crisis. Okay? So my point is, we are living in a dream world. The powers that be, the experts who should be guiding our thinking, are not raising these issues to any great extent. And as a result, here's my thing one, there is no global discussion that is taking place on the nature of capitalism. I could have said the economic system instead of capitalism, and where it's taking us. All right, now let's turn to our picture of the world summarized under Earth systems models. Well, here's a model as of 2009. And the point of the slide is to show that over time, the number of factors and processes that have been included in this Earth systems model has been increasing, which is all good. But missing in 2009, completely missing, was what people did and what people do. Now, here is a slide from the DOE, the Department of Energy, in which they're trying to explain to us what Earth systems models do. And there's the atmosphere, the ocean, the cryosphere, land, more and more physical sciences and some biology, and a little bit here, teeny thing here, human interactions with land, water, and energy. This is now completely backwards, as we know, because human activity is dominating many of these spheres. I don't know if you know, but I believe it's the fact that human flesh and the flesh of our animals, our domesticated animals, birds, cattle, etc., now constitute 96% of the mammalian mass on planet Earth, and everything that we call wild animals is now reduced to 4%. So my point is that we don't have an Earth systems model unless we start to think about how people behave. And so DOE wants us to think that the core science disciplines of an Earth systems model are things like math, chemistry, physics, etc. No, I would say going forward, we can't forget those things, but going forward, what we need are human specialists, social scientists, people who can tell us about how the economic system will evolve, the political system, international relations, and very, very important, human happiness. What will make our species happy in the future? We need to start thinking about this. Okay, so the net result is, thing two, there's no global understanding of Earth as a system for harboring intelligent life. And in particular, there are instabilities here that are inherent in our human way of doing business. Look back in the past, there have been rises and collapses, recessions and growth, et cetera, et cetera. The way we organize ourselves as humans seems to be inherently subject to these periods of rise and fall, and we don't really have any idea of how to tame them or control them. And lacking also is a vision of how many of us there can be and maintain a sustainable planet. So let me just criticize academia for a moment with our siloed approach to all of these problems. You can imagine that if we really had a well-informed analysis of how many people could exist sustainably on the planet, in order to calculate that, you would have to bring the Earth systems people, the atmospheric scientists, all of those people together. But you would have to understand energy, politics, resources, et cetera, et cetera. And you'd have to have a really holistic model, and it would take the whole university in a serious effort to put together that calculation. And we're not doing that. So that brings me to my thing 3, which is how we think about the future, the ethics of the future. And we can't really think about that until we understand where human ethical principles come from. And remember, a few minutes earlier in my talk, I confessed that are these lessons of cosmology. I confessed that these were my lessons. There were no miracles in our past, and there will be none in the future. That's what I believe. But that actually is an ethical statement, if you think about it. So let's consider where human ethical principles actually come from. There's a long history of this, obviously. Some of us here in this room may believe they are given by an external being, like God or something like that. Or you may be a Kantian, and you may think that they exist independent of people and God. They're just absolute. They're just there. I don't believe that. I subscribe to this view, which is called evolutionary ethics. It's a little bit new on the scene. Let's describe it. Ethics is simply a shorthand way for making tough decisions about conflicting goods. What do I mean by conflicting goods? I mean, here's a decision, I've got to make it. If I go this way, I'll have some good, but I'll have some bad. If I go that way, I'm going to have different good and different bad. Which way should I go? That's what I call conflicting goods. Now, in the sphere of evolutionary ethics, which, by the way, descended from all those fundamental concepts that we inherited from Darwin, all species face this problem. And they have evolved their own ethical systems to support their particular business plan. What do I mean by a business plan? What is a business plan of human beings as opposed to tigers? Okay. Tigers are solitary animals. They mate for a short time, but then the business of raising the progeny is basically the mother's problem. Contrast that with human beings. We live in groups, hunter-gatherers, historically groups of 100, 150 people or so, and raising and producing the next generation was communal. So it's natural, if I looked at the ethical system of a tiger, that especially that mother would be really focused on preserving her life and nobody else's life except the life of herself and her child. Whereas we as humans, we being coming on the scene as we have, we understand that first and foremost, we do have to preserve ourselves. So we have a selfish aspect. But at the same time, we depend for services and support on the people around us. And so there's care and concern for other people. This is the germ of many of the conflicts that we face when we are trying to make ethical decisions as human beings, ourselves first or our fellows first. Okay, but I'm getting ahead of myself. My belief is that ethical systems, including ours, have been honed by evolution, and we're no exception. Now, this is important when we go to the next point being, how do we value the future? The future is the subject of my talk. As we all know, decisions that are being made by human beings today are going to influence greatly the viability of future generations. So how much do we value the future of those future people? Okay, well, here is a sign that I came across in Santiago, Chile. Hay más futuro que pasado. There is more future than past. Actually, we hope that's true, but okay, let's assume it's true. Since the future is big, there could be lots more people. And in general, he would like to help more people rather than fewer. And so therefore, following this logic, we ought to ensure that the future goes well for generations to come. But implicit in this is whether we value those future generations. Do we? Not really. Here's one measure of how we value the future. It's called the exponential discount rate. So supposing somebody wanted to borrow $100 from you, and they said they would repay you in a year. Would you be willing to take $100 a year from now? Probably not. You don't think in those terms. You say, I could put my money in the bank and I could get $102 or $103. Why should I give you $100 for free at zero interest, right? So implicit in our economic system and also in our basic thinking as human animals is the notion that $100 in the future is not worth as much as $100 today. And why is that? It makes perfect sense because there's risk in the meantime. There's lost opportunity. Maybe I could take a trip to Mexico in 2 months from now and I'm going to miss that trip. I might die and you give me my heirs $100, but that doesn't really make me that happy. Okay, so all kinds of reasons, very practical ones, hard to ignore, mean that in practice we tend to devalue the future. Okay, so let's be economists for a moment and use a 2% discount rate. What does this mean for you in thinking about your retirement years? Well, here's the calculation. It means that if you're in your 20s and you're thinking about your retirement years, if you thought about them in terms of dollars, you'd only be valuing them at 1/3 your current year. Do you really feel that way about your retirement years? I don't think we do. So this is an indication in our own personal lives that this dollar discount way of thinking about the future doesn't really reflect our feelings about the future. And the problem is that if you apply a 2% discount to future generations that are, very far in the future, they're worthless. They're just not worth anything in dollar terms. And people planning projects now, will I build a nuclear power plant? Will I invest in, I don't know, a new technology for irrigation, et cetera, et cetera. Real people making real financial decisions are applying these discount rates. And this way of thinking is affecting all kinds of ways in which our society is investing in the future or not, as the case may be. Okay, so to summarize, we have a weak moral organ for the future just because, in my opinion, we haven't needed one, a strong one, to get to where we are now. Living as we used to do 1 million or 2 years ago, we were focused on daily life getting a meal for that day and for the next week or so, we didn't really have to think in terms of calculating our strategy for activities. We didn't have to think on time scales of many human lives. Okay, so as a result, thing 3, there is no collective consensus in our society on the origin of human ethics, where they come from, and here's my point, the relation of those principles to how we should plan Earth's future, or either whether we should even talk about that. Okay, so we're not in good shape, actually, to think about where spaceship Earth should be driven in the next few decades. But I want to bring this talk now down to more practical value for you and discuss 5 trends that I think you should pay attention to. Before I introduce them, let me just say, how's the time? Fine. Let me just say that I think you're in a different position from where I was at your stage, okay? So I'm assuming 20s thereabouts for your age. At that point, that's when I came to Santa Cruz. It was 1972. As it turns out, the 70s were an absolutely crucial decade in the history of our politics and our economic policy. I don't have time to discuss that, but we went off the gold standard. We had 2 energy shocks, and soon afterwards, Ronald Reagan teamed up with Margaret Thatcher, and the 2 of them hatched what we call neoliberal global capitalism in the early 80s. As I think back to myself in that decade, I was more or less oblivious to all of this. I was a new assistant professor. I was making lectures. I was, observing at the telescope and all of these things. My head was down. All of this stuff was going on up here. And it didn't matter, because somehow the society was resilient enough or had enough momentum that my world went on regardless in a good way, and I didn't have to pay attention. One of the things I want to make to you guys is I don't think that's true of your world today. And I know you're busy and totally consumed by the work in the laboratory and so on. But I urge you to start sticking your head up and looking around, because what's going to happen here could affect you personally. And let's talk about these 5 trends. The first is global warming. I think the establishment is converging on 3 degrees as the most likely warming trend by the end of this century. I think a very regrettable thing is that, with one exception, which I'll show you in a second, I don't think anybody is trying to actually describe what a 3-degree world looks like. Until a while ago, before I got interested in these issues, 1.5, 2.5, 4. What difference does it make? Why? I had no picture, okay? And I think, again, another criticism of academia, it would be very useful if all of these disciplines came together and converged to try to answer and give to people a working image. What will that 3-degree world likely look like? With one exception here, and I'm going to show it to you, academics are not making these things very tangible. And here's the exception. This is a group of people at Exeter University in England, led by Tim Linton. And they've written a couple of papers on a topic in which they call the human environmental niche. To make a long story short, they see where people are living today. They imagine a temperature rise. They use a climate model to figure out how that temperature rise globally will translate into local rises. And then they ask themselves, is that little square kilometer on Earth habitable anymore without air conditioning or electricity or some modern convenience. So here is a rise globally of 2.7 degrees, and the purple regions are regions that they deem will become uninhabitable with a 2.7 degree rise. And they didn't do 3 degrees. This is 3.4, okay? So the net result of their work, their prediction, is that a third of the world's population, 3 billion people, will either have to move or die if global temperature goes up by 3 degrees. I don't know about you, but this got my attention because I could easily imagine, my heavens, you know, these people are not going to sit still. They're going to move well before this. Well before you can't live in India, you can't raise crops. Your crops probably are not thriving anymore. You can't work in the heat of the day. You know, what are these people actually going to do? They are going to move. And that's another thing that you should pay attention to, because migration statistics are actually showing that this is beginning. Some percentage, maybe 20% of our immigrants who want to come to the United States from Central America, one learns on talking to them that they are motivated by the fact that their farms are failing. So we need more studies like this, going beyond mere habitability, but coming back by 2 to 3 decades and trying to answer what people are going to do in advance of this real catastrophe. Okay, so here's my next trend, the amount and cost of energy. Here's another thought I'd like to leave you with. We like to think somehow that we are great technologists. All those poor Romans, you know, yes, they made wonderful cement, but they're not as smart as we are. Those poor people who use sails to sail the seas, you know, we're so much smarter. We have gas-fired turbines and motors, coal-fired boilers, and so on. No, I firmly believe that the thing that distinguishes our age is a lucky thing, and it was the discovery of cheap energy, starting with coal and then later oil. And just think how much we depend on that. Greta Thunberg is telling us, just stop using it. That's not realistic. It's not realistic because the lights would go out, and worse, the trucks would stop running, and we would not be able to buy food in the supermarket. It's about a week before society as we know it crumbles if you were to cut short our consumption of energy. So we need much more nuanced response to how we're going to respond. And why do I say respond? Because probably we're beginning to see the peak in oil. That might be good because if we burn less oil, there's less CO2 emission. But on the other hand, there's an awful lot of coal. And will we continue to, are we so addicted that we'll continue to burn the coal? Okay, so as energy disappears, becomes more expensive, pay attention to the trade-off between the impact on your expenses, the cost of living, your standard of living versus the rate at which the climate is warming. Okay, the next thing to pay attention to is human demographics. This is another major trend that's affecting the world. These are birth rates as a function of time. The blue line is replacement value, 2.1 or 2.2 births per woman. And here are some recent birth rates in mainly developed countries. The poster child here is South Korea, the red line. They are now at 40% replacement value. Okay, what does that mean? That means that every successive generation, every 20 years, the population is only 40% of what it was before. What does infrastructure look like? What are all those empty schools doing that used to educate people? Empty buildings everywhere. Not enough people to maintain the freeways that were built at peak population. There are just so many implications for this. Good ones, in the sense that there are fewer people making environmental demands on the planet, but these other economic trends that are adverse. And remember, a while ago, I mentioned that capitalism really depends on growth and to attract new funds and investment. And historically, over the last 150 years, the growth of capitalism has come roughly 50-50 from population growth and growth in technology productivity. So if the population is stagnant or declining, that takes away a major motor from the growth that powers capitalism. And it brings the economic system at risk. And that's my next topic, shaky finances and shaky governments. Countries around the world, almost without exception, are swimming in debt. A hero of mine, Nate Hagans, who runs a podcast called The Great Simplification. He's an environmental economist, and he has calculated that if you wanted to repay these debts with real goods and services, other than just worthless pieces of paper, then you're making a claim on the environment. The resources have to come from somewhere. And the level of today's indebtedness is bigger than all the resources in the Earth's crust if you were to try to repay the debts in real terms. So the conclusion he draws is these debts are not going to get repaid. There's not enough resources in the Earth's crust to do that. What are the outcomes? One outcome is massive defaults and bankruptcies, but the one I'm mentioning here, which is important for you, the other way that governments at least discharge their debt is they debase the currency. And the way they do that is to cause inflation. And the way they do that is by printing money. So there's much discussion in the press these days about the Federal Reserve, and Powell is trying very hard to keep inflation under control. In coming years, though, inflation, it may be impossible because US debt is as large as it is. Why do you care? Because if you're dependent on a paycheck in dollars only, you are earning less. And so you need to think, and I would start thinking soon, about how you are going to hedge your resources in such a way that your income will be preserved if this period of inflation sets in. Okay. I'll just say a very quick word here about the last line here. And actually the second two last lines. Sandy's rule, the rich get richer and the poor get poorer. And this has been happening in the United States over the last 50, 60 years. And it is everybody's mission in politics, government, the media, to not say this. There's just complete dishonesty and ignorance and looking past this problem. It's now getting to the point where wealth inequality is serious enough that we're seeing resentment politics. Many people are feeling as though they're left behind. There are academics who study the instability of societies when wealth inequality gets too large. And that's a threat to the stability of our society that we need to worry about. So you should be reading the news and watching what people are saying. And don't disparage these folks who, when they are complaining about being looked on and looked down and devalued by the academic establishment. No, they have real problems and real issues, and we need to sympathize with them and help solve them. Okay, here's my last one, artificial intelligence. This is probably the nearest term problem that you guys should be thinking about. There are two schools of thought. I'm trying to learn about this myself with difficulty. Two schools of thought. One is that so-called artificial general intelligence will be developed within a decade, and that's the end of the human race. Some people say, the computers will take over and manage our environment, and we either go extinct because they don't need us, or we become enslaved. I have no thoughts about that really, because it's beyond my ability to imagine. This is the bigger issue for the folks in this room. Even today, as you know, you're using it. AI is very good at pattern recognition and writing, and that's much of the work that we do here as highly trained cognitive workers. And so even at 2, the impact on our society will be profound. I'm just wondering whether all those conservative lawyers who voted for Trump in the last election, if they're now out of work in the next presidential election, how their politics might change. But I'd like to call attention to academia, higher education, as this is the petri dish where all of these forces with AI are going to come to a focus, because both teaching and scholarly work might conceivably be done better by AI, in which case, what are we all doing here in the future? Okay, so now all of that was kind of grim, but actually I don't feel grim. Let me close here with this slide. What do I think you should do? The first is, and I said it before, become well-informed, be aware, look ahead, and think at least a decade ahead for you and how you're going to adjust. But the good news here is that unless we have a nuclear war, these changes are going to take quite a while. You have time. So it's not as though there's an emergency tomorrow. You will be working. I think the rules in the workplace are going to change, especially if AI is displacing some workers. My advice to you is don't be average. Make yourself useful. As my dad said, stand out and become irreplaceable. You want to be that person. You want to be the last person that they let go. Because you have PhDs and advanced scientific training, or scholarly training more generally, people will automatically see you as leaders. That PhD will open doors for you. Live up to that expectation. The next point may strike you as a little odd, but it's very practical. Ensure your personal security by building your own community, starting with a family. If society is not dependable or as dependable to serve your needs in future, you need to think about building your own community that will do this. And there's nothing like a family. I have 2 children, not 10 of them. No, it doesn't take that many. I am so grateful to have that family. Now, they comfort me, and I know that they'll be there for me if I need them. I would give that advice to you too. There will be numerous opportunities. Doors will open for you. Think of those 2 Hubble postdocs. The doors opened, they saw they had something they could contribute, and they walked through them. But it takes courage. Have that courage. And then finally, I want to appeal to your professional expertise. I've complained that academia is not living up to its obligation to convey visions of real future worlds, possible future worlds. That's what people need in order to make decisions now. It's going to be very hard to derail the forces of capitalism if you don't use the ballot box. Ultimately, I think what people in society think is going to be the deciding factor. They don't know what to think. They're not being given any consistent vision that they can work with or understand. This is where you could come in. Whether you do it for pay or whether you do it on your own time as a volunteer, I urge you to think about that. So, in closing, I think there will be many rewards for the folks like us in this room. The best thing that's going to happen, in my opinion, is that the capitalist edifice will dwindle and disappear. It just won't be supported by the growth forces that we've had in the past. And a leveling of society will occur. And I, as a liberal person, consider that to be a good. There's going to be a return to age-old values of community relationships and nature, the importance of the environment. People will come to understand in a way that they don't today, that this is key. It's going to be exciting. There's going to be something new every minute. And I firmly believe you guys are going to live through what I think is the most consequential transition in human history, in which we try to do two things. We try to live within the limits of the planet, but at the same time, hang on to the indispensable aspects of modernity, public health, science knowledge, medicine. We don't want to lose those things. How are we going to support those activities with a smaller population and a smaller energy budget? I do believe there's a solution. Probably depends on having fewer people overall. But your generation is going to answer that question. So thank you very much. Let me just say that I have one more slide, and I'm happy to share these slides. This was a list of resources that I've enjoyed using to learn about these larger world events. And I'm happy to share the slides, and in particular, this concluding slide, if you're interested in taking advantage of it. Okay.
Do you have any questions?
I'll be great at the question. Yeah, that's what this is on, but I'll just use my own voice. Okay, so, wow, what a brave and vulnerable thing you just did today, and I'm so happy that you came to talk to us. And as someone who really values community, one of the things that I see most pressing in my generation is the loss of community. And so I wanted to put a plug in and really ask for your advice about the idea of reciprocity. And this idea of reciprocity of giving and taking from communities is really taken away by capitalism. And I want to put a plug in for Robin Kimmerer's book, Reading Sweetgrass, which is using indigenous wisdom to rethink how we engage as scientists with our communities and also with Faber. So if you haven't read this book, it shaped my life, and I would recommend reading it. So I guess I'm really curious to hear under that overarching principle, like how scientists in a world that is becoming increasingly AI driven, how do we hold on to reciprocity? How do we hold on to a community-based perspective where that brings us all in the room right now? All of us are here together. We're here on our own time in a world of capitalism that's selecting against that. So I just would love to hear from anyone, really. Like, and this is an open question, what your thoughts are.
I'll go first since I'm here. Okay, that's a wonderful question. We have been dismantling those opportunities pretty systematically, especially post-COVID. I did give a specific task to you guys, and that was to help society envision the future, not solutions, but just help people think about what's going to happen. That is the occasion for community activity. That can bring people together, how you talk about that, how you construct that vision, and how you share it with the rest of society. That would be my first and foremost example of how groups like you guys can come together in the future, sharing with each other and with society more broadly.
Let's go ahead and break for lunch. Of course.
Let me just reiterate that I'm looking for feedback. Come and speak to me over lunch. Thank you.